Well, hello everyone, and welcome to today's webinar featuring Nylex's ACE fiber reinforced asphalt technology. My name is Ed Ma, and I'll be your moderator today. First, I'd like to introduce our presenters. Michael Simons is Nylex's Business Development Specialist for Pavement Systems. Michael is a licensed professional engineer in Ontario with over 25 years of experience in the design and construction of geosynthetics in North America. Our second presenter is Kevin Louie. Kevin has been with Nylex for 31 years and has held titles such as Major Project Team Coordinator and MSC Project Manager. In these roles, he was responsible for managing many of our large P3 civil projects. In his current role as Business Development Specialist for Nylex's roadway systems, Kevin is able to pull from this experience and find innovative and efficient solutions for today's owners, roadway designers, and builders. Before I hand it over to Michael and Kevin, I have a few housekeeping items to cover. First, this webinar will be recorded and emailed to all of you in the next couple days, so feel free to rewatch it and share it with your colleagues. Also, we'd love to hear from you throughout the presentation. If you have a question for our presenters, please type it into the questions tab in the control panel, and I'll read them to the presenters during the Q&A session at the end of the presentation. And finally, professional development credits are available for this webinar. If you'd like to receive your PD certificate, please email us at info@nylex.com. Now, without further delay, I'd like to kick things off by welcoming Michael Simons. Over to you, Michael.
Thanks, Ed. Welcome, everyone. Thank you for joining us today for this webinar. Well, paving season has just started in some parts of the country, so we thought it might be timely to talk about a material that many owners are starting to use, fiber reinforced asphalt pavement. Some of you may already be familiar with this technology through past webinars that Nylex has hosted, or perhaps from actual project usage. For others, this will be an introduction to a new technology. So Kevin and I have divided this webinar into two parts. First, we're going to talk about the technology of fiber reinforced asphalt pavement, and then Kevin will discuss how and where ACE fiber has been used throughout Canada. We're going to keep this presentation at a high-level overview, so we may not go into depth on any specific topic. Please do not hesitate to ask any questions that you have as we go through the webinar. As Ed mentioned, just type it in the box. And Kevin and I will try and answer the questions at the end of the webinar. Before we go any further, I'd like to acknowledge and thank our manufacturing partner, Surface Tech. They're the ones who developed this technology, so we'd like to thank them for helping bring this to Canada. So what is fiber reinforced asphalt pavement? Well, let's look at the key differences between conventional asphalt and fiber reinforced asphalt pavement, or FRAP. Standard asphalt is basically rock single, where FRAP includes aramid with micro roots which grab and anchor into the asphalt cement, or the good. Standard asphalt in the field has low tensile strength, where FRAP changes its behavior into fibrous tensile solid. It's a three-dimensional reinforcement. Standard asphalt is temperature susceptible, meaning that during hot days and in cold days it wants to shrink. In hot days it wants to get soft and under loading, start to move or rut, and during cold days it wants to shrink and start to crack. Whereas on the other hand, FRAP has high strength, which basically resists that movement and that cracking, so it improves the performance of the pavement. Standard asphalt is a non-uniform chemical bond between asphalt and rock. However, the aramid fibers add a certain consistent mechanical reinforcement to that mix, helping to increase the bond. And eventually, over time, asphalt cement will oxidize and start to break down. The presence of these fibers can help resist some of that breakdown and still to improve the performance as the mix gets stiffer, leading to potential cracking. In trying to increase the structural capacity and extend the surface life of an asphalt pavement, while desirable, it is difficult to do and achieve, and when you consider all of the external stresses acting on the pavement. You've got environmental stresses, you've got top-down stresses, you've also got bottom-up stresses. Any flexible pavement is only as good as the aggregate base. So in order to maximize the performance of of fiber reinforced asphalt pavement, this is reliant entirely upon having a good base. The idea of adding fibers to asphalt pavement is not a new idea. It's been tried for over 30 years. The material that started to come out as very beneficial to helping with this is a material called aramid fiber. So what is aramid fiber? Aramid fiber is a synthetic high-performance fiber. While the term aramid may not be familiar to everyone, many of you are familiar with at least one form of aramid fiber. There are a number of manufacturers across the globe that produce aramid fiber. One of the companies, DuPont, their trademark aramid fiber is Kevlar. The material itself, as Kevlar, has been used in a number of industries to replace and supplement the performance of many products. So it's a new, interesting, high-performing material, and because of the characteristics of the material, it's uniquely fitted towards working with asphalt cement pavements. The fiber itself has 5 times the tensile strength of steel. But because it has a very low strain, it means that it's a high modulus material, which makes it very effective at reinforcing asphalt pavements. Aside from the tensile strength, one of the biggest factors that helps aramid work within an asphalt pavement, it's got an extremely high melting temperature. The melting temperature at 425 degrees is well in excess of the typical temperature ranges in which we're making asphalt pavements. So there is no possibility of the fiber melting during the mixing process. So that combination of high strength, low strain, and temperature sensitivity of the material makes it a very effective reinforcement for asphalt pavements. Now, some of you may be familiar with fibers used in asphalt mixes already, specifically SMA mixes. Aramid fibers are not used in SMA mixes. Typically what's used is a cellulose fiber. The aramid is not the same as cellulose. Aramid fibers are meant for reinforcement. Cellulose fibers are meant to absorb asphalt cement and prevent drain down in SMA mixes. So how do the aramid fibers work within an asphalt pavement? The key to the performance of the fiber, not just with the strength and the strain relationship, but it's actually the nature of the fiber itself. The fiber is not a smooth, straight fiber, like something like fiberglass. The key to the aramid is the entire structure has lots of little fibrils that are along the shaft of the fiber, and these are free to basically grab onto anything that they're in contact with. A lot of times they'll be in contact with the aggregate particles, the large and the small one. The fibers are going to wind up grabbing onto anything, but the fibers also have the ability with those micro roots to actually bind into the asphalt binder if that's all they're in contact with. And to just see what that structure looks like under a scanning electron microscope, so the image on the left shows what these microroots look like. Now just imagine that in contact with your aggregates and with your asphalt cement. This is going to grab onto everything that it can. So the picture on the right is basically showing what the material can look like. The image on the left is untreated aramid fibers. This was taken from some lab work that was done. The end product, after mixing and delivering to the site, is in the image on the right. So the aramid fiber is what's reinforcing the material, but trying to get that into the mix can be a little challenging. So this product that has been developed, ACE XP polymer fiber, this is what we are using to reinforce the asphalt pavement. So what is ACE fiber? ACE fiber is a simple combination of Kaizen aramid fiber and Safety-Bit wax. We're adding 65 grams of each material per ton to create 130 grams of ACE fiber. Several spools of aramid fiber are spun together to create these bundles. So those little yellow sticks, if you will, they're actually bundles, but each one of those bundles has over 10,000 fibers within each bundle. The aramid melts at 425, so it's nowhere near the manufacturing temperature of the asphalt, but the sassabit wax melts at 77 degrees Celsius. So as these fibers are introduced to the asphalt plant, the wax is melting, releasing the fibers into the dry aggregate as it's mixed, creating this reinforcing material. I mentioned that the aramid fibers are not the same as cellulose fibers. Aramid does not absorb binder. So by adding this to any asphalt mixture, we are not actually changing the job mix formula or requiring any sort of additional asphalt cement within the mix. So the fibers are available in two sizes. Why two sizes? Well, think long hair versus short hair. If you run your fingers through longer hair, you will have a greater interaction or snagging of your fingers with the longer hair. So the increased length means greater resistance to the stresses imposed on it. If you will, think along the lines of a bond development length in concrete. You've got greater resistance, you've got longer fibers fighting the external stresses on the asphalt. So these longer fibers give you slightly better performance than the shorter fibers, but there's no additional cost. So the longer fiber we're recommending because it's slightly better performance and no additional cost to the shorter one. The shorter one is where the industry sort of started off, but the longer ones are proving slightly better. And for no additional cost, it makes a lot of sense. So how does the longer fiber perform versus the shorter fiber? So there's a lot of lab work that's been done in the United States. And what we're basically finding is that we get the better performance for the same price. But the flexibility index shows testing it's almost a 37% increase over a control mixture with the longer fiber. So because you're increasing the flexibility index, it's suggesting that the longer fibers improve the cracking resistance of the asphalt pavement. Flow number testing also shows a 37% increase over control mixtures, suggesting that the longer fibers improve running resistance of the asphalt. The 19 millimeter fibers also showed this increase, but not, it was only a 30% increase, not a 37% increase. So hence a slight performance increase over the shorter fiber, but for no impact on the cost. It makes a lot of sense to go with the longer fibers. We're still using the same mass of fibers. It's still that 65 grams per ton of aramid. It's still the same surface area. You just have half the number of fibers, but they're longer fibers. So how do we make fiber reinforced asphalt pavement? What do we do with this ACE fiber product? Quite simple. Basically, we add it to any drum or batch plant, and typically we are adding this where you add in your wrap. We want mixing of the fiber with heated dry aggregate, and we're looking for 25 to 30 seconds mixing time prior to hitting it with your binder. So you're giving the material a good chance to melt and mix with the aggregate and bind with the aggregate before you add the asphalt cement to the mix. Depending on the size of the project and your asphalt production schedule, so is it a one-day project, is it a little bit over a number of days, the fibers can be added using either a manual system or an automated dosing system. Typically, we are just blowing these fibers into, as I said, through the wrap collar in most plants or into the pug mill on a batch plant, and we're getting good mixture with the material. So by adding these fibers to your mix, it improves the performance of your mix. But what does that mean? So adding aramid fiber to a good mix will improve the performance of the pavement, but it's not going to modify the job mix formula. It'll improve the cracking, rutting, and fatigue resistance of the mixture. It will not stop the asphalt from cracking, but it will take longer for the cracks to appear. And when the cracks do appear, they're going to be a much smaller size. So when you think about it, especially if you're looking at a reflective crack going from the bottom up, the entire layer of pavement is now reinforced with the fibers. So the crack has to work its way through an entire reinforced matrix. So when it does daylight, it's not going to be as wide as an unreinforced material would have it. So ultimately, the performance of the pavement, though, will depend on the condition of your aggregate base. You can have a great pavement, but if you've got a lousy aggregate base, you're still going to have a lousy pavement. This might be a really good quality Band-Aid, but ultimately you haven't fixed your problem. Your problem is still base related. Now, how do we come up with those numbers? As a new technology, the testing of the fiber reinforced asphalt pavement is an ongoing project. Much of our current testing program is focused on material characterization for use with NAPDG pavement design methods. This is a list of some of the agencies and universities in the U.S. that have done testing with it. University of Alberta is in the process of conducting studies right now looking at different types of fibers for use in asphalt pavements. So much of the research testing has been done in the U.S., but as owners in Canada start to use FRAP, Canadian consultants are starting to work with this material in their labs. So some of the Canadian labs that have done various forms of testing with the fiber, and this could be in-depth mix design, it could be simple QA testing, but we've dealt with companies like SNC Lavalin, the City of Edmonton, Golder Associates, and Englo, just to name a few. There is a technical summary. That image on the right is basically a 32-page technical summary that summarizes all of the testing that's been done to date on the Nylex ACE fiber. So how do we quantify the benefits of adding this material to your mix? So we're going to improve the rutting and cracking resistance of the material, but one of the takeaways from all the testing that we've done is to look at the effect of using a reinforced pavement versus an unreinforced pavement on a typical pavement design. So what this chart is showing, if we take a pavement design, 150 millimeters of aggregate base on a competent subgrade CBR5, if we vary the thickness of the asphalt and compare an unreinforced mix to a reinforced mix, what we're able to do by adding the fibers is actually adjust, in the National 93 design method, we're able to actually adjust the layer coefficient for the asphalt layer. So typically, we're using between 0.4, 0.42 in Canada. We can bump this up to 0.5, 0.52, so a 30% increase. This chart was done by our colleagues in the US, so they use a slightly higher value, start off they based on 0.44. But if we look at their calculations, for really thin reinforced pavements, there's not a lot of difference, thin being a 2-inch pavement on top of 150 millimeters of base. But if you increase that, so by the time you get to 150 millimeter asphalt pavement, simply looking at the amount of traffic it can handle, the ESO count, we're almost 3 times the ESO value, which is going to impact or translate into your service life. And this makes a lot of sense when you're thinking that we're actually adjusting the performance of the material, the mixture itself, the asphalt mixture. We're creating a better performing material using these fibers. So I've spoken a little bit about what this material is and how we make it and why we do this. But how do we get this used into contracts? How do we specify this in our projects if we really want to use this? It's an engineered material. So basically the way we can build a generic fiber reinforced asphalt concrete specification, focus the specification on the properties of the airment dosage, the fiber length, and how it's going to be delivered. So 65 grams per ton, that is what we're focusing on. That's the active ingredient, if you will, the aramid fiber. The length of the fiber is important. Better performance with a longer fiber. Continuous stream of fiber. If we feed in the fiber on a constant stream-like feed, so we're adding fibers entirely as you make the mix. We're not dumping this all in at once. So we're not pulsing it, if you will. This is a continuous stream. As you add in the aggregate and the binder, we're adding the fibers just like you would that. You're paying extra for this material, so it makes sense to ask for some verification that it's in there. So daily mixing logs should be a requirement. But also, at the end of the job, you do your QA, your QC testing. These fibers can be recovered from samples taken. We can use simple chemical extraction and recover the fibers. So we can build a specification around these, and it's a good, solid technical spec. And a lot of municipalities in Canada are using generic specs based on this technology. So with that, if you've got any questions on the technical aspects of it, I will turn this now over to my colleague Kevin, who's going to talk a little bit about where we can use this material and where it has actually been used. So Kevin, I'm turning this over to you now. The screen is yours.
All right. All right, thank you, Michael. Again, thanks everyone for joining us today. It's great to see the interest level in this technology and this product. We've had another good number of people register for the webinar today. So again, I'll talk about some product usage and some recent projects that we've had done last year. So let's talk about, just going to advance here. Sorry, I'm having troubles advancing my slide. Give me 2 minutes. Oh, there it went there. Okay, let's start by talking about ACE Fiber, more specifically what types of applications we've been using it in. Virtually anywhere you want to improve the performance of your asphalt, ACE Fiber is a good solution there. We are going to add strength to that mix. When we talk about thin layers is a good spot too as well. So bridge decks where you have thin layer asphalt, areas where you have urban infrastructure conflicts, which the meaning we're obviously tied to curb and gutter a lot of times. There's shallow surfaces, so we can't deepen our structure. Those types of applications again, or perhaps where you have increased easels and usage of a roadway, and again, you can't build any bigger structures, so that would be a good spot there as well. We do a lot of parking lots as well. Moving to the heavy trafficked areas, we have been working a lot with airports, both in taxiways and runways. Industrial parks with heavy traffic, like truck routes and that. Bus lanes where oftentimes you will see a concrete apron. You get a lot of pushing, a lot of shoving, starting and stopping in that lane there, so that's a good opportunity there as well. And of course, roundabouts also produce a lot of pushing as well. So I also wanted to mention quickly just the possibility of using this in a remote site, so where materials may not be available readily and or a asphalt plant where you're bringing in a portable plant to do the work and then mow back out again. If you can extend that life again by a couple of years and not have to bring that asphalt plant back again, that might be a good opportunity as well for the ACE Fiber. Okay, so ACE Fiber cost. Let's talk about that for a minute. So we are currently using about a $15 a ton premium right now for the ACE Fiber, and that includes the ACE Fiber material and the dosing and the QA/QC documentation that Michael mentioned too as well. And that price is a contractor price. You could also look at it in an overlay sense. So a 50 millimeter overlay, this will work out to less than about $2 per square meter, to give you a sense in that manner. And then a lane width kilometer, so 3.75 meters wide, kilometer long would cost you about $7,500, to give you a sense in kilometer range. One box of ACE fiber will cover just over 1,100 square meters out of 50 millimeter overlays. So the boxes come in a 40-pound box and reproduce about 138 tons per box. Okay, so let's talk about the dollars, the benefits we talked about, the extended service life and whatnot, and what we want to do here is, of course, we want to extend the service life. We want to increase the years to the next rehab or the next overlay. And but let's put it into dollars and cents. So if you're able to hold off on that overlay by a number of years beyond, every square meter of a 50 millimeter overlay that you save doing is new spend, and that new spend can range anywhere from $15 to $27 a square meter. And that, of course, varies across the country, across the regions, and, of course, due to materials and availability of asphalt plants, that type of thing. But that is your range that you can spend elsewhere. So, again, if you have other priority roadway rehab projects, that's a good place to spend that money. Perhaps there's more urgent repairs or emergency repairs that need to be done, and that's where that $15 to $27 a square meter can be used. So who's we've been working with in 2018? We've got over 20 installations across Canada in 2018. We've been across the prairies through Alberta, BC, into Manitoba, Ontario, Saskatchewan, and then we also have some work done in the Northwest Territories. The reinforced asphalt pavements have been used by MTOs, airport authorities, municipalities, private owners. A lot of those people are developers and asset management companies as well that own asphalt. Of course, we use it on major highways, taxiways and runways, municipal roads and parking lots. And this material can be used, again, as a surface course as well as a binder course down below as well. So with that, I want to take you through a few jobs, again, that we have accomplished in the last year here. This one actually is back from 2017 for the District of North Vancouver. I brought this one up just for the fact that I was out there last week and met with the district out there, and I says, hey, could we go look at the pavement? And he says, well, there's really nothing to see. There's no cracking, there's no rutting, there's nothing going on there. So they did say it was performing well, but that was done in October 2017. BA Blacktop was the producer and installer of the material. It was about a 500-ton project. We used 19 millimeter fiber in that. It was on the Upper Highway, Mountain Highway project. So 500 tons, we dosed that in a day. It was done manually with the hand dosing of the line back machine. And that project was a 65 millimeter overlay. Moving on to Leduc, this project in Alberta last year in July. Carmex was the producer and installer of the material. There was 4 separate sites, and of these sites, there was about 12,000 tons of material used in total. There was a 38 millimeter fiber being used. This was dosed both by the automated machine, and then near the end of the project, we had to ship it off to another project in Saskatchewan, so we finished it with the manual dosing. It was Alberta Des 1 12.5 millimeter mix with about 20% wrap. 3 of the projects wore overlays, and 1 was a full depth asphalt. So another thing that the Leduc County wanted to do is, as this was a good trial for them, they went out and did some extra testing. So they had their consultant hire a testing lab within the city here, and they tested the FRAP versus the control. So that raw data is now back, but we'll reserve comments until the full report is released, which should be soon. So, moving on to Southern Alberta, the City of Brooks. This was done by Brooks Asphalt. It was about 11,000 tons of 38 millimeter fiber. The project location was Castle Roads. It was about 12 days of mixing. They had some rain and whatnot in between this project, so it extended out to about 16 days, I think, total. But it was the MD3 automated dosing machine again, and the large projects, of course, we try to use that machine because you could be standing there dosing for a long time with these larger quantities. So this was a Type 1, Type 2 City of Brooks mix. It was a 75 millimeter overlay. Moving over to Ontario in September, the region of York in Ontario, Deep Krupe and Sons were the installer of the materials. About a 9,000 ton project. 9,000 ton project. 38 millimeter fiber used on this Yonge Street project. This one was actually done at night, so there's 5 nights of dosing. It was hand dosed, and as I mentioned, our equipment was busy at the time, so they had to hand dose that. So that was 5 long nights of dosing. This was a 19 millimeter super pave mix with a 70-28 oil. Again, all night paving with this one, and they used the material transfer or shuttle buggy for the installation of this material. So, back into Alberta now, October 2018. This project stemmed from the City of Brooks project, and Brooks Asphalt again was the contractor on this one. About 2,800 tons was installed here. It was about 5 days of mixing time. It was the automated dosing machine again as well. It was an AT Type L1 asphalt mix. It was a 52-34. It was a 50 millimeter overlay. And again, they were using shuttle buggy here too as well, or material transfer vehicle as well. And then this one here is YYC in Calgary. Again, this project stemmed from the Hanna Airport now. Standard General was a contractor. It was a small 500-ton size project. I believe it was 38 millimeter. It was a 1-day mixing time. We did it by hand with the line back. And it was a PG 70-31, 65 millimeter overlay. So it's been impressive how one project can lead to another. As more parties get interested in material and they're hearing about the material, we're just doing more and more work in that manner. So, all right, I want to give you, I guess, a little more in-depth understanding of who's using this material and whereabouts we've been in 2018. So, not a full case study by any means, but I want to give you the names of the components or proponents that have been using the material. So, City of North Bay, Ontario, 38 millimeter project. You can see the 3 with the MTO, and Ontario is really taking a liking to the material. You can see that a couple of these projects were on Highway 401. So again, a very busy highway, obviously in Canada. Region New York did a couple of projects, one of which I spoke about, the Yonge Street project, but they also did a project in Vaughan, 38 millimeter on the old Highway 7. Lennox and Addington County, there's a couple of projects, 3 projects in total there, all 19 millimeter fiber. Coke Construction Storage Yard, again, we're talking about some private developments. The GTA, Greater Toronto Airport Authority in Ontario and Toronto. Again, taxiway, a 19 millimeter fiber project. Vaughan Mills Mall is another one that was the private development too as well. Moving into Saskatchewan, this was a large project. I think it was about 40,000 tons for Melville, Saskatchewan. City of Brandon on Pacific Avenue. And then we're moving into BC now with Tillicum Road in Esquimalt. Did a project last year. And then BC Ministry of Highways and Transportation. You can see where they're using here bus loops in Vancouver and Langley. So again, where we have heavy loading, starting and stopping, repetitive motion. So they did a couple of projects as well in 18. BC Hydro, which is a very large owner of asphalt in BC. Moving into Alberta, so now we got City of Brooks again. They've, again, that's when I showed you Lakeshore Development in Yellowknife was a project we did last year, and unfortunate thing is we had just finished the project, and we had gone away, and they phoned later and says, oh, the plant burnt down and some of your equipment got scorched. But I guess that's the hazards of working in the industry. So there's the 4 for Leduc County. Again, 4 different applications, and again, we got some testing coming back from that. Town of Golden did a project in Golden, BC, 38mm fiber, and then again, YYC Airport. So finally, I do want to tell you now where we're going this year. Again, we've been busy over the winter months and into the spring here talking to different folks again about fiber reinforced asphalt pavements. And so in 19 so far, we're looking at a number of sections coming up. So in Skillen Township, South Frontenac Township in Ontario as well, municipality of Chatham-Kent, the York region, Lennox and Addington County again are doing some more this year. City of Oshawa will be trying it this year. Town of Halton Hills, Ville de Brocherville will be going this year. Sorry, Town of Blue Mountains, Ministry of Ontario again are signed up to do some more this year. CN Rail, that project is in Ontario as well. YVR, we'll be doing some work there in mid-May. City of Grand Prairie has a project out now closed and should be going in the July months. Town of Cochrane, Town of Brooks again is doing another project this year again with us. And then some more Ministry of Highway and Transportation up near Fort St. John. So let's give you a sense, I guess, where we're going this year with Ace Fiber. And again, after this, if there's any potential applications you may have, we'd be happy to discuss them with you. So at that, I will say thank you very much for your time and attention, and I'll hand it back to Ed for any questions that may have come up.
Well, thank you very much, Kevin and Michael, for that. Yeah, we do have quite a number of questions coming in online here. So if you do have any questions, please feel free to enter into the question box on the control panel, and I'll read them out to the presenters. Just get started here. Maybe a question for you, Michael, I believe. Question is, have these fibers or similar been investigated for use in concrete reinforcement?
Probably, but aramid would be very expensive in the dosages that you would use for concrete reinforcement. So it's not something that we're actively engaged with. And I think the benefits you'd get, you're probably going to find that the current usage of other synthetic fibers and the steel fiber is going to be probably a lot more economical than the aramid fiber. It's not a cheap material to deal with, but it makes sense for the asphalt and the quantities that we're dealing with.
All right, thanks, Michael. Another one for you here, Michael, regarding dosage. Would the dosage be 65 grams per ton of aramid fibers and 65 grams per ton of sassabit wax? Is this not what should be specified?
Good question. No. The active ingredient is the 65 grams of aramid fiber. The 65 grams of sassabit wax is added to the fiber merely to weigh it down. The wax does nothing. It's nothing more than a treatment. The sassabit wax itself is soluble in the binder, but it's not affecting the performance of the mix, so it's not doing anything other than just weighing it down. So the active component that you want to specify is the 65 grams of aramid fiber. The sassabit is a treatment, and who knows what's going to happen. There could be other products that come onto the market that may treat the fibers differently, but you can build your specification around that 65 grams of active material. And that's basically what the MTO does, is that they're specifying the active ingredient, and then the treatment is extra on top of that.
Excellent, thank you. Over to you, Kevin. Question is, do you design differently with ACE fiber? For example, can you reduce the amount of asphalt?
Typically, we don't. Well, we don't design any differently with ACE fiber. It doesn't change anything. Obviously, in the asphalt mix design itself, it purely is an additive to add strength and resiliency to the product. Again, going back to one of Michael's slides there, we can effectively increase that strength coefficient of the asphalt to show a stronger layer. How we've been going to market typically is we are looking at producing the same pavement, the same thickness, and adding performance and longevity to the structure. We can and will look at if the occasion arises in regards to perhaps trying to shorten or to lessen the layer or the thickness of that surface course. But at time being, we are looking more so at the performance versus trying to reduce asphalt layers thicknesses.
All right. Back over to you, Michael. What does the typical QC program related to the fiber look like?
So what we're basically doing is, when we set up at a plant, we want to keep the dosage of 130 grams of fiber, the ACE fiber per ton. So we need to know what production speed the plant is operating at, so we know what sort of, what amount of fiber to add per minute, per 30 seconds, however we decide to do it. We need to determine how much mass we're putting into the mix on a continual basis. And the QC documentation records the amount of fiber that we've used over the time frame. So we're including starting and stopping. So basically, at the end of the project, what we're doing is we're producing a report that basically says this much material was used, this was the time frame, this much asphalt was produced, this was the time frame, this was the amount of fiber that was added to it per ton on a continual basis. And we'll generate a report at the end of that. At the moment, Nilex is providing this service to contractors, but as we go forward, contractors are starting to inquire about having us train their own employees so that they are doing this. Nilex is happy to work with those contractors and essentially provide a manufacturer certification of the reports that they're doing. So if they're providing us with the documentation of what's being done, we're prepared to say this is meeting the manufacturer's requirements.
Okay, thank you, Michael.
Ed, that's just the dosing. If you want to recover the fibers from lab testing, there is actually a modified testing standard that is available that I can provide to people. Okay,
thank you. Kevin, our municipality has been using glass grid geotextile for years between overlays with some rather impressive results. Would the fiber-infused asphalt be on par as far as strength goes, a suitable replacement for glass grid?
Yeah, we believe so. The test results we've seen coming back in regards to the reduction of reflective cracking and some of the overlay tests would show that for sure. The little bit, I guess, the advantage of it is glass grid is an interlayer product, so it's actually going between two layers. So it's can be a challenge for installation if it's installed correctly. It is a very good product and very effective product. But oftentimes some pavers do struggle with the installation of a glass grid, whereas ACE fiber would be into the mix. Again, this doesn't change any of the handling techniques that a paver would do. And again, we would expect the same performance or better performance in reflective cracking or transverse cracking resistance with the ACE Fiber, yes.
Okay, thank you. Michael, maybe this one you can answer. It's a two-part question. What is the primary purpose of fiber reinforcement, and how did you determine increase in strength, rut resistance, etc.?
Great question. So we're adding the fibers to improve the performance of the mixture. And as we've said, if you've got a good mix, good aggregate, decent amount of high quality asphalt cement, this will improve the performance of that without modifying that job mix formula. The benefits that we presented have been developed over many years of testing, both lab and field testing, and that the image I presented of the technical summary, that's a 32-page document that summarizes all of the individual tests that have been done. There's been approximately 30 lab and field tests that have gone on over the years, and there's ongoing testing right now onto the performance of the fibers. So I'd be happy to share that summary and those reports with anybody who's looking for it.
All right, thank you. Kevin, for small paving jobs, could you add the fibers at the paver? For example, for small paving jobs, could you add, sorry, it's the same question. Can you add it at the paver for small jobs?
No, we need to have a certain amount of mixing time. We need to be mixed in with the heated aggregates to release the fibers from the sassafras wax before the oil hits it. If we try to add the paver, the oil is already present, so that wouldn't work. It needs to be mixed either at the drum plant or at a pug mill or at the batch plant.
Okay. Michael, for you, nowadays many crushing plants and landfills are producing recycled asphalt product, or RAP, often taking in used asphalt at no cost. Would the used fiber infused asphalt be accepted at these facilities or rejected because of the fiber being present?
Great question. We haven't gotten there yet. Because this is new technology, the generation of RAP using this technology is very, very rare. I'm only aware of one project. Was actually, from my understanding, there was a little bit of an issue with work that was done at Leduc last year, and they wound up milling up some of the material. And that's the first instance that I'm aware of fiber reinforced asphalt pavement being milled. And there was no impact on using standard milling machines. But the reuse of the RAP, let me rephrase it, acceptance of that material shouldn't be an issue because the fibers actually add value to that RAP, and going forward would impact positively the performance of a mix. But we haven't actually had the situation specifically where RAP had to have been taken to a facility and accepted or rejected. We're not there yet.
And if I could, I'll just jump in quickly. That so I did talk to the paver that had to mill up that material in Leduc, and they noticed no difference. It came up just like any other asphalt. To be honest, they couldn't remember. The material went back to the plant. They don't know where it went for sure, whether it went back into mix or back into a recycled pile. But again, there was no noticeable difference of the material. What they said is they wouldn't have noticed that there was fiber in it or not when they put it back into a pile in their yard. So yeah, that was I guess what they had said there, that there was no noticeable difference. So.
All right. Maybe this one's for you, Kevin. The appearance of the asphalt surface course with fiber seems to be a bit rough as compared to the appearance without it. Has any roughness testing in terms of IRI, etc., been done on this surface?
Not to my knowledge. To be honest, I've been on a few jobs now, and And again, it's very hard. You don't see the fibers in the top mat, where you may pick them up a little bit in the mix as it ravels off to the sides of the roadway, but you don't physically see it. So if it's looking rougher, I think that's I guess probably more of a result of what the mix is and consistency of the mix. The fibers should not change that. And to my knowledge, there has not been any testing. Michael, do you have anything further on that?
No, not aware of any IRA testing. And as Kevin said, the roughness of the surface is more a function of basically the placement, the contractor workmanship of the material. The presence of the fibers isn't going to affect the roughness or the coarseness of that mix. It's more the mix and the placement technique.
Awesome. Maybe staying with you, Kevin, do you recommend ACE fiber for base asphalt, 150 millimeters versus top lift, 50 millimeters?
It can be used in both sections. Wherever we're using ACE fiber, we are going to strengthen that layer of material. It could, I guess, depending on loading. If you do have a roadway where you have a lot of repetitive heavy loads, maybe you want to pick up that load higher up in the structure, so we might use it in surface course versus down below to maybe stave off some of the rutting more so. But again, it could be used both top and bottom. Again, we prefer to see it being used in both, and we're just going to increase the strength again of the entire structure.
Okay. Michael, another question regarding research. Has there been any long-term performance research?
The technology is roughly 10 years old. So there's not, I wish I could say we had 25 and 30-year studies on this. It doesn't exist. The long-term that we're dealing with right now is looking at projects that are, 5 and 6 years old and seeing how they're performing. And based on that right now, the owners are quite pleased with a lot of the results. There is the expectation that the asphalt will eventually crack, and they are seeing that, but it's happening over longer periods of time and it's not as severe. But any long-term organized study, I'm not aware of it being done right now.
Okay.
I think that's what some of the ministries of transportation are setting up, is they're doing their trial sections to see and monitor to see how this works. And well, this is a good tool. It's not going to solve all of your problems with roadway mixes. So where this is being used, why it's being used is important. This may, like a good example, on a composite pavement. If you're not treating your underlying rocking of the slabs, then reinforcing the overlay might buy you a little bit of time. It might not if you've got some serious rocking of the slabs in there. If you've got serious subgrade issues, this is not going to solve those. With any pavement structure, if you've got base problems, you've got to fix the base to really solve the problem on that.
All right, thank you. Here's a question regarding regarding fiber length here. Maybe for you, Michael. Sounds like the longer fibers are more beneficial from a performance point of view. Where would you use the shorter fibers, and is there a cost difference between the 19 millimeter and the 38 millimeter?
I would use the 38 millimeter everywhere because there is no cost difference. It performs slightly better, as I mentioned, but because there is no cost difference, a lot of owners that are trying this material are just defaulting right off the bat to the 38 millimeter fiber because there is no cost. There is no cost impact on using the longer one. The shorter one, the usage, some of the older projects, it's a zombie spec, if you want to look at it that way. Some of the ministries of transportation that have been using it for a couple of years started off with the 19 millimeter. So those specs still reflect that. But as we do more projects, they are interested in looking at the longer fibers as well. So really, we recommend the 38 millimeter everywhere. It is the better performing fiber.
And if I may, Michael, just to jump in here, just to clarify, so if we're using 38 millimeter versus 19 millimeter, we're still using the same amount by weight, but we're physically using half the amount of fibers because they're twice as long. But even at that, we are seeing a better performing material with the 38 millimeter fibers versus a 19 millimeter.
All right. Maybe one for you, Kevin. Has Alberta Transportation trialed this product yet?
Not as of yet. We've had some conversations with them. Michael is part of the TAC committee and has had some higher level conversations, but to date, not as of yet, but we are looking at hopefully this year getting a spot to try it with them.
Okay. And staying with you, Kevin, I think, is it recommended for surface lift? Any issues with exposed fibers at the surface leading to aggregate pickout?
No, we haven't seen any of that so far. Again, if you walk a mat after it's being paved with ACE fiber, you got to really look hard to find anything. Oftentimes we go out and we're on site paving or watching the paving process, and oftentimes because we're known as Nilex to be in the clay subgrader and the aggregate base, oftentimes they'll look at us and say, "What are you guys doing here?" And so when we say, "Well, we're seeing how the ACE fiber is performing in the asphalt," and the crews don't typically even know. They don't see it until it starts to pick up on the rakes after a number of hours on site. So again, it's something that you don't see. It's not cause a problem with any segregation whatsoever in that manner.
Okay. And also for you, Kevin, what % of life cycle extension do we expect to see?
And again, we're still working on some numbers here in regards to the longevity increase. Like Michael says, we don't have a long-term study anywhere. The product is 10 years old. Again, we're increasing the strength and performance in the AASHTO design code by 20 to 30%. So we're thinking that we're going to get anywhere from a 30 to a 50% increase in the life of the asphalt.
All right, fantastic. Well, we're running right up to the hour almost here. We've got a few minutes left, so I'm going to ask maybe just a couple more questions. If we don't get to your question, because we received a lot of them, if we don't get to your question, either Michael or Kevin will respond to you directly. And if you have any questions for Michael or Kevin, you can email them. We'll send out their contact information with the recording that goes out. So just with the last couple of minutes here, I'm going to ask maybe a question for you, Michael. Does this material leave any residue in the drum or pug mill?
Great question. On all the projects that have been done in North America, no contractors have ever complained about there being any residue left in their facility. We show up, we add it, and we leave, and that's it. There's no modification to the plant required. There's no residue left in the drum.
Okay, great. And maybe one last question before the hour is up here for you, Michael. Using AASHTO, we apply a structural coefficient of 0.4 for asphalt concrete in structure thickness design. Using these fibers, has there been any research done to increase the structure coefficient? Great
question. Yes. A lot of the field testing that has been done is actually back calculated out the in situ layer coefficients of the asphalt layers. And specifically for an AASHTO 93 model, you can take your 0.4 or 0.42 and increase it by 30%. that's probably conservative, but stick with no more than 30%. So your 0.4 is going to go to 0.5, 0.51 with that sort of layered coefficient. It's come out of the actual field testing that we've done.
Well, fantastic. All right, well, we're right at the 1 hour mark now. I just wanted to thank everyone for attending. Again, the webinar has been recorded and will be sent out to you for you to review or share with your colleagues. And again, if you have any, or if you require your professional development credit certificate, please send an email to info@nilex.com. I'll also include that in the recording email. And if you're in a, like many of our attendees are, in a boardroom with several people attending, if you can send us the list of people as well, and we can also provide them with the professional development credits, that would be fantastic. So with that being said, thank you very much, and have a great day.
Thank you.